Imagine writing C# code where you constantly create new objects directly. New keyword here, new keyword there, it can get messy, right? This approach often leads to tightly coupled code, making it hard to change later. What if you need to introduce a new object type? You'd have to modify every single place where you created the old one. Not ideal, especially as your projects grow larger. Let's say you're building an application to manage different types of vehicles like cars, trucks, and motorcycles. Each vehicle has its own set of properties and methods. Creating these objects directly can quickly clutter your code and make it hard to maintain. You might find yourself repeating similar code blocks for each vehicle type, which violates the "don't repeat yourself" or DRY principle. This direct object creation approach can also make your code more prone to errors. If you forget to update all the object creation points after making changes, you'll likely run into bugs. Testing becomes more challenging as well because your code is tightly coupled, making it difficult to isolate and test individual components. In essence, while direct object creation might seem straightforward initially, it can quickly become a maintenance nightmare as your project scales up. This is where the factory design pattern comes to the rescue, offering a more elegant and maintainable solution for object creation in your C# applications. The factory design pattern provides a better way to manage object creation. Think of it as a dedicated factory in your code, responsible for producing objects. Instead of directly creating objects using the new keyword, you ask the factory to do it for you. This might seem like an extra step, but it offers significant benefits in terms of code flexibility and maintainability. The core idea behind the factory pattern is to encapsulate the object creation logic within a separate entity, the factory. This factory class provides a method or a set of methods to create objects. When you need a new object, you call the appropriate factory method, passing any required parameters. The factory then takes care of instantiating the correct object type and returns it to you. This approach provides a layer of abstraction between your code and the concrete object types. You no longer need to know the exact class names when creating objects, you simply interact with the factory. This makes your code more flexible because you can easily introduce new object types without modifying the code that uses them. Let's imagine a busy coffee shop. Customers come in and order different types of coffee: espresso, cappuccino, latte, you name it. Now imagine if the barista had to brew each coffee from scratch every single time, measuring beans, grinding them, and preparing the espresso machine for each cup. It would be chaotic and slow, right? This is where a coffee machine acts like a factory. It provides a simplified interface for the barista. Instead of going through the entire process manually, they simply select the desired coffee type on the machine and press a button. The machine handles the complexity of grinding beans, brewing espresso, and frothing milk, delivering a perfectly crafted cup of coffee. Similarly, the factory design pattern in C# provides a streamlined way to create objects. You interact with the factory, requesting the type of object you need, and the factory takes care of the underlying complexities of object instantiation. This abstraction simplifies your code, making it easier to manage and less prone to errors. Let's bring the factory pattern to life with a C# example. Imagine we're building a simple game with different types of enemies: goblins, trolls, and dragons. Each enemy type has its own unique characteristics, such as health points and attack power. C# / define the enemy interface. Public interface IEnemy int health points get set, int attack power get set, void attack / concrete enemy classes. Implementing the IEnemy interface public class goblin, IEnemy / goblin specific implementation. Public class troll, IEnemy / troll specific implementation. Public class dragon, IEnemy / dragon specific implementation. / factory class for creating enemy objects. Public static class enemy factory, public static, enemy create enemy string enemy type. Switch enemy type, case goblin, return new goblin. Case troll, return new troll. Case dragon, return new dragon. Default throw new argument, exception, invalid enemy type. / usage in the main method class program, static void main string args, IEnemy enemy, 1 = enemy factory, create enemy goblin, enemy 1 dot attack, IEnemy enemy 2 = enemy factory, create enemy dragon, enemy 2 dot attack. In this example, we first define an IEnemy interface that all enemy types must implement. Then, we create concrete classes for goblin, troll, and dragon. each implementing the IEnemy interface with their specific logic. The enemy factory class acts as our factory, providing a createEnemy method. This method takes an enemy type string as input and returns the corresponding IEnemy object. In the main method, we can now easily create different enemy objects using the enemy factory without needing to know the concrete class names. This approach keeps our code clean, flexible, and easy to maintain. Section 5, DB Provider Factory, a real-world use case. The factory pattern isn't limited to theoretical examples, it's widely used in real-world applications. One prominent example is the DB Provider Factory class in .NET, which provides a way to interact with different databases without tightly coupling your code to specific database providers. Imagine you're building an application that needs to work with both SQL Server and Oracle databases. Instead of writing separate code paths for each database, you can use the DB Provider Factory to create database-specific objects like connections and commands based on configuration settings. This approach makes your code more flexible and maintainable. You can easily switch between databases without modifying your core application logic. The DB Provider Factory handles the low-level details of connecting to and interacting with the chosen database. Section 6. Advantages of the factory pattern. By now you've seen how the factory pattern simplifies object creation and enhances code maintainability, but its benefits extend further. First, encapsulation. The factory pattern hides the complexities of object creation from the client code. Clients interact with the factory, not the concrete object creation process, simplifying their interaction and reducing the potential for errors. Second, loose coupling. The factory pattern promotes loose coupling by decoupling the client code from concrete object types. This makes it easier to introduce new object types or change existing ones without breaking the client code, enhancing flexibility and maintainability. Third, testability. The factory pattern improves testability by allowing you to easily substitute concrete object types with mocks or stubs during testing. This isolation makes it simpler to test individual components in isolation. Fourth, code reusability. The factory can be reused throughout your application to create objects, promoting code consistency and reducing redundancy. Finally, centralized control. The factory pattern centralizes the object creation logic in one place, making it easier to manage and modify object creation rules in the future. Section 7. Beyond the basics. Exploring more patterns. The factory pattern is just one example of a creational design pattern in software development. As you dive deeper into the world of design patterns, you'll encounter other powerful patterns like the abstract factory, builder, and singleton patterns, each addressing specific object creation and management scenarios. These patterns provide proven solutions to common software design challenges, helping you write more maintainable, extensible, and robust code. Exploring these patterns will equip you with a valuable toolkit to tackle complex software design problems effectively. Section 8. Conclusion: level up your C# design skills. Mastering the factory design pattern in C# is a significant step towards writing cleaner, more maintainable code. By encapsulating object creation logic within a factory, you gain flexibility, reduce coupling, and make your code more resilient to changes. Remember the coffee shop analogy: just like a coffee machine simplifies the barista's job, the factory pattern streamlines object creation in your C# applications. Embrace this pattern, explore other creational design patterns, and elevate your C# coding skills to the next level.